Chapter 2, Polynomial and Rational Functions, Section 2.2, Quadratic Functions. The objectives for this section would be to recognize characteristics of parabolas, graph parabolas, determine a quadratic function's minimum or maximum value, solve problems involving a quadratic function's minimum or maximum value. The highlighted objectives would be the main focus for this section. The standard form of a quadratic function would be f of x equals a times the quantity x minus h squared plus k. So when you're looking at a quadratic function, if it's in the form f of x equals a times the quantity x minus h squared plus k, then it is in standard form. Keep in mind that a cannot be equal to 0. The standard form is very important. You will have to memorize it. The standard form will easily give you the vertex as well as being able to figure out what the symmetry is based on x equals h. You'll be able to look at it and evaluate whether the function opens up or down for the graph. If a is greater than 0, which is positive, it opens up. If a is less than 0, which is negative, it opens down. The standard form will help you easily be able to evaluate those particular characteristics, and you will have to memorize the formula. Graphing quadratic functions with equations in standard form. Again, when the function is in standard form, f of x equals a times the quantity x minus h squared plus k. There are a few steps that you will have to follow, and the next slide will go through each step separately, modeling an actual function in standard form. You'll have to determine whether the parabola opens up or down, determine the vertex, find the x and y intercepts, then plot it and find additional points if you need them to plot. So let's take a look at the next slide with the example. Let's look at the example of graphing a quadratic function in standard form. Graph the function f of x equals negative of the quantity x minus 1 squared plus 4. Notice that above the function I wrote the standard form in general with the variables above the terms so that you can easily see which term represents which variable. All right? So the first step is to decide whether it opens up or down. So let's take a look at the A. The A is a negative 1, so negative means that it opens down. And there is a picture to the right that you see a parabola that opens down. Next thing is we have to find the vertex. The vertex is your h value and your k value. Remember that h is an x value and k is a y value. So in order to find it, you just look at the function and find the position that the h is supposed to be in. The h is right here, and then your k is right here. So you will get your ordered pair 1, 4 as your hk, and that is the point that represents the vertex. Please keep in mind that h is an x value and k is a y value. So step 3 would be to find the intercepts for the x-intercepts. Remember that the x-intercepts mean that your y is 0. So f of x is 0. So when you find your x-intercepts, you'll have something for your x, but the y value will be 0, and we're finding what our x values need to be. Okay? So let's take a look. We're going to substitute 0 in for the y. In this case, we are using f of x instead of y. So here you can see that the 0 is substituted for f of x is basically substituting 0 for y. Once you do that, now we have to solve for x. The next step would be to move the 4 to the left side. You would do that by subtracting 4 from the right and subtracting 4 from the left, and the 4's on the right hand side will cancel out. 0 minus 4 would lead you to a negative 4, which we have here. So now we have a negative of the quantity x minus 1 squared. So I want to get rid of this negative 1 right here. So in order to get rid of the negative 1, since it's multiplying, I could divide, but since it's a 1, an easier method would be just to multiply. So I'm going to multiply both sides by negative 1. And on this side, negative 1 and this would be positive, so they'll cancel out. And negative 1 times negative 4 would give me a positive 4. So the next step will show the exact process I just iterated. So you can see that we went from this step to this step, and that was done by multiplying both sides by negative 1. Now I need to get rid of the exponent 2 right there. Since it's a square, I can do the opposite of squaring, which is square root. So I'm going to take the square root of the right side, so I can cancel out the square. If I take the square root of the right side, I also have to take the square root of the left side. So when I take the square root of the right side, the square disappears, and I end up here with just x minus 1. However, when I take the square root of 4, I have to account for the positive and negative because it's a regular number. Remember that negative 2 squared equals 4, and positive 2 squared also equals 4. So we have to make sure we account for both of those. So the square root of 2, the square root of 4 is plus and minus 2. And now we have x minus 1 equaling two separate values. So as we go over to the right hand side here, you see that we have x minus 1 equals a positive 2, and here we have x minus 1 equals a negative 2. We have to solve for them separately. So for the first one, we had to add a 1 to both sides, and these ones will cancel out, leaving me with just the x, and on the right, 2 plus 1 will give me 3. Here, we're adding 1 to both sides. These 1s will cancel out, leaving me with the x, but negative 2 plus 1 gives me a negative 1. So your x-intercepts, you already know that x-intercepts means the y value is 0. So I'm going to put 0 for my y values, but now I found my x values. So I'll just write them in where they are, and here we have 3 and negative 1. The x-intercepts are 3, 0 and negative 1, 0. The next step is to find the y-intercepts. Remember that for y-intercepts, the x values are 0 here. We plug in 0 for the x. So you put 0 in for your x, and we have to figure out what our y value is. In this case, we're calling it f of x, which will now be f of 0 since we're substituting 0 for x. So I rewrite the problem. Then everywhere that we had an x, like here and here, we substitute 0. And now we have to evaluate the right side of the function. So we are going to figure out, well, what is 0 minus 1? Here, 0 minus 1 is negative 1. So we end up with the negative on the outside. 0 minus 1 is negative 1. So in there is a negative 1 squared plus 4, which is my next step. And then we are going to have to square the negative 1. So you see this square right here? We're going to square negative 1. Negative 1 squared is a positive 1. So I have a positive 1 now, but the negative is still outside. So positive 1 times negative 1 will end up being a negative 1. A negative 1 plus 4 will be a positive 3. So let's go to the next step. Negative 1 plus 4 is a positive 3. And that means your y value is a 3. So earlier we had our 0 for our x. Here's our 0 for x, and we just figured out that y is 3, so we substituted here in the ordered pair. Now we're going to bring all the steps together. We found the vertex, the intercepts. Now we're going to plot each of the points. So we knew that it opens downwards because the a was negative. Remember, the a was a negative. So to open down, our x-intercepts right here, we have 3, 0. And here we have negative 1, 0. Those are our x-intercepts. We have our y-intercept of 0 right here, 0, 3. And we had our vertex of 1, 4 right here. So we just plot them, connect it with a smooth curve, and you have your graph of the quadratic function based on it being in standard form. Let's take a look at the vertex of a parabola whose equation is in the form of f of x equals ax squared plus bx plus c. Remember that your a is in front of the x squared term, your b is in front of the x to the first power, and your c is just a constant. Highlighted in the center is a formula that you're going to have to memorize. You really only have to memorize how to find the x. Then you'll be able to use that x value and substitute it into the function to solve for y. So your x function is the opposite of b over 2a, or you could just say negative b over 2a. Once you're able to find that value for x, you're able to substitute it into your function, which we're calling f. But instead of x, we said f of negative b over 2a, which is this x value that you just found, and we substituted it in to find your y. So your x value is here, and your y value is here. They are both based on finding the opposite of b over 2a. You will need to memorize that formula. Now, graphing quadratic functions with equations in the form f of x equals ax squared plus bx plus c. Again, you'll have to determine whether the parabola opens up or down. You have to find the vertex. However, this time finding the vertex will require you to use these formulas since it's not in the standard form. And once you find the vertex, you have to then find the intercepts, which again require you to plug in 0 for either the y value or 0 for your x values. Then you plot the points and connect it with a smooth curve. Here, let's look at an example of graphing a quadratic function in the form of ax squared plus bx plus c. We're given f of x equals negative x squared plus 4x plus 1. I've annotated what each variable stands for. So our a is the negative 1 in front of the x squared, our b is the 4, and our c is the positive 1. So does it open up or down? We have to take a look at the a. Is a positive or negative? Well, a is negative, that means it opens down. So since it's negative, it opens down, there you have an example of a parabola that opens downward. Now we have to find the vertex. Remember, the vertex is based on the formula x equals negative b over 2a, or as I like to say it, the opposite of b over 2a. So you have the formula here, and we are going to just take the values for b and a, substitute them in, and solve. So we know that b is 4, so replace b with 4. We got b is 4 right here. We got negative 1 for a right here, so we have a b there, we have our a there. Remember that if I was to write this out in all the steps, you would have a negative, you have a positive 4 over 2 times negative 1 is a negative 2. This negative and this negative will cancel out, and you will have a 4 divided by 2, which will give you a, sorry, let me erase this, positive 2. And that's what they got. They just didn't show you the process of how they got that. So once you find the vertex, you can go on to find the intercepts. So we found the vertex. Well, we didn't find the vertex completely. We only found the x value of the vertex. That was the opposite of b over 2a, or negative b over 2a. Now, in order to find it, we have to substitute that value in, which we found out was 2. So we got 2, but in order to figure out what the y is, we have to substitute that 2 into the function. So instead of f of x, or f of negative b over 2a, we just replace it with 2, because we know that negative b over 2a is 2. So we save a little bit of space and just write 2 in there. What does that mean? It means that I have to substitute 2 in for x everywhere in the function. So negative 2 squared, put a parentheses around this, plus 4 times 2 plus 1, and evaluate. So here are the steps. Negative 2, well, 2 squared is 4, but the negative is still there because we didn't square the negative. 4 times 2 is 8, and then we have our 1. We add those up, we get a 5. So the coordinates now will become 2 that we found earlier, and now we have a 5 for the y, where 2 is our x and our 5 is our y. We found the y value by just plugging in the 2 into the function that we found earlier. The next step is to find the intercepts. We find the intercepts by substituting 0 in for either the x or the y. Here we're going to find the x-intercept. X-intercept means that the y is 0. Here we have our 0. We're going to substitute 0 in for our y. In this case, y is being called f of x. So here you see that we substituted 0 for our f of x, which is our aka y value. And now we have to solve. The solving process can be in many forms, but in this case we are going to use the quadratic formula. Remember that the quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac over 2a. Remember that we referred to the values under the radical as the discriminant. The discriminant has to be positive in order for the solutions to exist. If the discriminant is negative, the solutions are imaginary, and you can't graph imaginary numbers. So let's go ahead and substitute the values in. Here you can see that once again, since our a was our negative 1, our b was 4, and our c is a positive 1, we just substitute in the 4 for the b, negative 1 for the a, 1 for the c, and a negative 1 for a down here. Now we are going to evaluate the terms under the radical. Let me erase on the side and here so we can see. We're going to evaluate the terms under the radical. Remember that 4 squared is 16, so that's we have our 16 here. Negative 4 times negative 1 is a positive 4, times a 1 again is just a positive 4, so we have our positive 4 there. Now 16 plus 4 is 20. So we end up with 20 right here, but then we have to go ahead and evaluate the whole negative 4 plus or minus square root of 20 over negative 2. So we evaluated the positive one first, meaning not positive 1 but the plus. So we did negative 4 plus first, and we got approximately negative 0.2. Then we evaluated the minus, which is negative 4 minus the square root of 20 over negative 2, and we got approximately 4.2. So now we know that our y values are 0, and we got two different values for our x's, so we substitute those in for the x's, and we have our two x-intercepts. Continuing, we're going to find our y-intercepts. Remember that y-intercepts mean you plug in 0 for the x and you solve for the y. So we're going to do that everywhere there's an x in the function. We are going to replace it with a 0. So remember that 0 squared is 0 and a negative of 0 is 0. So that is just 0. 4 times 0 is 0, and then we're adding 1. Our final answer will be 1. So we knew that our x value was 0 because it's a y-intercept, and then we just found our y to be 1, so we have our ordered pair of 0, 1. So now let's take a look at the graph. We graphed all the intercepts and the vertex, so we have our two x-intercepts, our y-intercept, and our vertex. So here is our vertex. Here is your x-intercept, that is 4.2, 0. Here is our other x-intercept of negative 0.2, 0. Right here we have the y-intercept of 0, 1. And we also have an axis of symmetry. Remember, your axis of symmetry is your x equals h. Well, x equals h. Well, what is h? H is the x value in your vertex, so that's 2. So we're going to have to draw a vertical line to represent x equals 2. So no matter what y equals, x will equal 2. So this dashed line represents our axis of symmetry. Let's take a look at minimum and maximum. Based on whether your parabola opens up or down, you will have minimum or maximum values. If it opens up, you can clearly see that right here is a low point. If it opens down, you can see that right here is a high point. So the vertex on the one that opens down is your minimum. Your vertex on the one that opens up is your minimum. The one that opens down is your max. So if it opens up, you know that the A value is positive. So you know it has a minimum. If it opens down, the A value is negative. You know that it has a maximum. However, there is a distinction that you have to make between some notation, and I want you to pay very close attention because it can cause you to get answers incorrect. When it's asking where it occurs, you are given you're giving the x value of the vertex. This is the x value of the vertex. When they're asking where it occurs, if it's a max or a minimum, you're giving the x value. When they're asking you what it is, you are giving the y value. So it says the value of y, or f of negative b over 2a, gives the minimum or maximum value. When they're asking you what is the value of the minimum or maximum, you give your y. When they're asking your the location of the minimum or maximum, the x value gives the location of the minimum or maximum. So please make sure you know the difference, or it could cause you to get the problem incorrect. Where it occurs, or what is the location, you're giving an x value. If they're asking you the value of the minimum or max, then you are giving a y value. Where or location equals x. value. And these are based on the vertex, okay? Remember your vertex? Oops. Your vertex is your h comma k, right? H is your x and k is your y, right? When they're asking you where, you give the x. When they're asking you the value, you are giving your y, okay? So let's look at an example. Obtaining information about a quadratic function from its equation. We're considering this function f of x equals 4x squared minus 16 plus 1000. It says determine without graphing whether the function has a minimum or maximum value. Well, does it open up or down? Right here, that's your a value. A equals 4. Is that positive or negative? It's positive, and you know that positive means it opens up. If it opens up, it has a low point here. Your vertex is your minimum value. So they're telling you the same thing there. Look at the A. If you need to make a quick little sketch, do that. And you can see whether it's a low value or a high value, so you can determine if it's a min or a max. Consider the quadratic function, find the minimum or maximum value, and determine where it occurs. So they're telling you find the value and where. Remember, where is an x, value is a y. So we're going to list our a, b, and c. Remember, a is right here in front of the x squared. B is in front of the x, and C is your constant, so they've listed it there. You're going to substitute the values into your x equals the opposite of b over 2a formula. So here we substituted negative 16 for our b. Here we substituted 4 for our a. You evaluate it. 2 times 4 is 8. The negatives, this negative and this negative, cancel out and become positive. So now you have 16 divided by 8, which is 2. So your x value is 2, so that is where it occurs. Now the value of it is a y value. How would you find your y value? You substitute your x, which is your opposite of b over 2a, into the function. But since we know that x is 2, since we did all the work already, you're just finding f of 2, which means substitute 2 in for all the x values in the function. So here we go, where there was an x in front of the 4 becomes 2, and it's now 2 squared. Next to the 16, where it was an x, it also becomes a 2. We are going to square the 2 first. 2 squared is 4, and 4 times 4 is 16, which we have right here. Negative 16 times 2 gives me a negative 32, and of course the 1000 just stays here. And you evaluate that, your final answer will be 984. The 984 is your y value, and your y value is the value of the maximum or minimum. The where was the x. So here they're telling you the minimum value of f is 984, and the value occurs at. So once again, pay attention to the notation. The value is the y. The where it occurs at the x, okay? So let me make a little notation right here. This is a y value. So the value is a y, occurs is an x. Now we have to find domain and range without graphing. So based on what we know, we have to think about what domain and range mean. Well, domain would be your x values, right? And your range would be your y values. Range is y values. So think about it. If my parabola opens up like this, I have a low point here. So this is the lowest value that I'm going to have if I'm looking at it in an up and down manner. Up and down would correspond to y values, right? So if I'm looking at it up and down, it opens up and I can see that here is the minimum, which is the lowest y value. That means whatever that value is will be the value here for my range, or make this brackets. The value here for my range would be my min, right? And then if you look at it, it goes up forever. So then I would end up to positive infinity for the right end. Not the right end, the upper part of my range. Then we're going to take a look at one that opens down, right? We're opening down. That means you have a high point where your vertex is, and that means this is a maximum. That means the highest that this would go is whatever this y value is for your range. All right? So then the lowest point, since it goes down forever, would have to be going towards negative infinity. But the highest would be whatever that max value is, which is the vertex. Write this. And if you look at a parabola, whether it's opening up or down, it's opening up, it's going to the left perpetually, and then it's going to the right perpetually. Remember that left and right, these are x values. So these would be values for your domain. Here, even though it's going down, it flares out to the left perpetually and to the right perpetually. Again, we're going all the way to the left and all the way to the right. Again, these are your x values for your domain. And all the way to the left is a negative infinity. All the way to the right is a positive infinity. So the domain for your parabolas will pretty much be negative infinity to positive infinity. However, your range will be based on whether it opens up or down. Remember, up, A is positive, down, A is negative. All right? So let me erase all of these notations so I can give you the stock information they have provided. But draw pictures, think about it logically. It says like all quadratic functions, domain is negative infinity to positive infinity. We found the vertex at 984. It has a minimum value at the vertex, and the range is from 984 to positive infinity. So remember, we said that this is a positive A because A was 4. Remember in the function A equals 4 from the top? That is positive, so that means it opens up. That means we have a low point. We have a low point. We have our low point around here, which is the vertex. And this is the lowest point. That is going to be your lowest value for your range. And since it goes up forever, it's going to positive infinity for your range. Let's take a look at solving a real world or word problem using a strategy for solving problems involving maximizing or minimizing quadratic functions. You'll have to read the problem carefully, use the conditions that they have given you in the problem to express the quantity as a function in one variable. Then you have to rewrite it in the form of f of x equals ax squared plus bx plus c. Calculate your negative b over 2a. Substitute it back in to the y to find the y, and maybe rewrite your answer in regular verbiage. So I know that's a lot to take in, so let's take a look at an example. An example of maximizing area. It says that you must have 120 feet of fencing to enclose a rectangular region. Find the dimensions of the rectangle that maximize the enclosed area. What is the maximum area? Now, we have a few pieces of information. We have that you have 120 feet of fencing that encloses it. Since it's enclosing it and it's in a rectangle, I know my rectangle is not the prettiest, but hey, let's look at a rectangle. And if we're just using up and down and left and right, we've been calling left and right X, and we've been calling up and down Y. Now, this is just a sketch. We don't actually know if this is what the rectangle is going to look like, but just for visual purposes. And all around it is, if you add them up, it's supposed to be 120 feet. And that we refer to as the perimeter. The perimeter is 120 feet. And we know that a rectangle, opposite sides are equal. So that means you have an x, x, and a y, y. That means you'd have a two sides that are equal to x values and two sides that are equal to y. And if you add them up, you're supposed to get 120 feet. They're asking for us to find the dimensions of the rectangle that maximize the enclosed area. What is the maximum of the area? So first, we have to decide what we have to maximize. Let me erase some of this. First, we have to decide what has to be maximized, and it blatantly says it in the problem. It says, what is the maximum area? So obviously, we are maximizing the area. It says it right here. And then it says maximum area, so that's what you're maximizing. The next step is to express this quantity as a function in one variable. So if you remember that area, the formula for area of a rectangle is length times width, but we're dealing with x and y here, so we're calling x and y the length and the width. All right? So we know that we have 120 feet of fencing, and that's the perimeter, and we know that twice the side that we're calling x plus twice the side that we're calling y needs to add up to be 120. So right now we have two separate equations. We have one right here, a equals xy, and we have one right here, 2x plus 2y equals 120. The x's and y, we have them in terms of x and y so that we can be consistent with our variables, because we're going to need to combine them in the following steps. Now we have to solve for y. All right, let's take a look at this side right here. Here, we took this perimeter equation and we move the 2x to the right side. So let me rewrite it in the center so we can follow the steps, because they're not given in the PowerPoint standardized. So I had to subtract 2x from both sides, and these will cancel out. I'm left with 2y equals 120 minus 2x, which is what we have here. All right? So with that, we have 2y equals 120 minus x. Now I want to get rid of the 2 because I just want to solve for y. Well, how would I solve for y? Since 2 is multiplying to y, I have to divide by 2. Whatever I do to the left side, I have to do to the right, so I divide both sides by 2. 2 divided by 2 is 1, which means they cancel out, and I'm left here with y by itself on the left side. However, on the right side, I have 120 minus 2x divided by 2. And if you break that apart into 120 divided by 2 minus 2x divided by 2, you can see that your 120 divided by 2 gives you 60, and the minus in the middle, and then 2 divided by 2 cancel out as 1 or equals 1, so you get your x right there. We end up with 60 minus x is what y equals. And now we're going to take this y, because we're dealing with a system of equations. I'm going to take this y, go over here to my area formula, and instead of x times y, I'm going to replace y with what we just found out that y was, which is 60 minus x. So here, instead of a equals x times y, it's a equals x times 60 minus y. Now, we have to distribute the x to each term. X times 60 is 60x. X times negative x is a negative x squared. If we rearrange it in order from highest exponent to lowest, we have our negative x squared in the first position, our positive 60x next, and we don't have a constant, or you could say our constant is 0. You could write plus 0 if you want a c to be there, but it's not necessary. Now, since we have it in the form of ax squared plus bx plus c, we can figure out what our a is, what our b is, and what our c is. Well, a is negative 1 because that's the number in front of the x squared. B is a positive 60 because that's the number in front of the x. And our c is a 0, which we don't need. But if you needed to know what c was, c is 0 because it's not there. So now we're going to substitute those values into the negative b over 2a formula. When we do that, you are solving for your x. So we substitute the 60 in, the negative 1 in, we simplify, and we get a 30, which is positive. Remember that these negative signs, this negative right here and this negative right here, cancel out, and you end up with a positive 30. So the positive 30 is your x value, and it says a is less than 0, so the function has a maximum. So we're going to look at the a value. We see that a is a negative 1. Since a equals negative 1, we know that it opens down. So I'm going to draw a quick sketch right there. Since it opens down, this high point right here is our maximum value. Says this means that the area, which we're calling a of x, of a rectangle with perimeter 120 is a maximum when the rectangle's dimensions x is 30 feet. So since we know that it opens down, it has a high point. That high point is the maximum. The maximum occurs, let me write it in red. The maximum occurs at x equals 30 feet. Now we have to figure out, well, what is it, the actual value of the maximum then, when x equals 30 feet? Okay, so in step 5, we're going to answer the question that they asked in the problem. The problem stated that you have 120 feet of fencing to enclose a rectangular region. Find the dimensions of the rectangle that maximize the enclosed area. And what is the maximum area? Well, find the dimensions. We already found that x equals 30 feet, right? So if x equals 30 feet, that means that 2x plus 2y equals 120 feet. We just substitute in 30 for the x. And this is 60 plus 2y equals 120. You subtract 60 from both sides. 2y equals 60, divide by 2, and we divide by 2, and you get y equals 30. So x equals 30, and y also equals 30 feet. Okay? So they're asking what are the dimensions that would maximize the enclosed area. So we had x, so we just substituted and found y. So we know that dimensions would be 30 feet by 30 feet. That will cause the rectangle to have a maximum area. And they're asking what is the maximum area. So now they're not asking where it occurs or what's the location, or in this case what will cause it to be the maximum area, or what dimensions will cause it to be maximum area. They're asking you for the actual value of the maximum area. What is the maximum area? And we know that is a y value. All right, so since we know that's a y value, we have to figure out what that y value is, because that's our area. Remember, since area is what we're looking for, we are considering it our y value, even though we're calling it a of x, because we're going to put in our x value and solve for the area. So negative and 30 squared plus 60 times 30, and you'd get a positive 900. Remember, feet squared. Remember, area is always squared because it's one unit times another unit. In this case, it'll be feet times feet, or foot times foot, which will be feet squared. All right, so let me erase this and give you the stock version. It's in here. Here they forgot to put in the 30. That should be a 30. And your final answer is 900. Therefore, the maximum area is 900 square feet. You can say square feet or feet squared to represent area.